Good morning, children. Let us proceed on to exercise 8.3, problems based on scalar product. Question number 4, find the angle between the vectors. Consider the two vectors as A and B. Let us recall the formula angle between A and B. Theta equals cos inverse vector A dot vector B by modulus of vector A into modulus of vector B. How are we to calculate A dot B? For dot product, we multiply I and I components 2 into 6, J and J 3 into minus 3, K and K minus 6 into 2, 12 minus 9 minus 12. So A dot B equals minus 9. The next step, let us find out modulus of A. Modulus of A, root of, add the squares of the components, 2 square plus 3 square plus minus 6 the whole square, that is 4 plus 9 plus 36. 36 plus 4 is 40 plus 9 49 and the square root is 7. As we proceed on to modulus of B, again squaring and adding 6 square minus 3 the whole square plus 2 the whole square. It is 36 plus 9 plus 4. It reduces to 49. The square root is 7. Let us substitute in the formula cos inverse. A dot B is minus 9. Modulus of A is 7. Modulus of B is 7. We cannot cancel, so the answer is theta is cos inverse minus 9 by 49. Second subdivision, find the angle between I minus J and J minus K. Treating the two vectors as A and B. Recall the formula angle between A vector and B vector is theta equals cos inverse A dot B by mod A mod B. How are we to perform dot product? I and I. Here I is 1, here I is missing. Plus J and J minus 1 into 1 plus K and K. Here K is missing, so 0. Here K is minus 1. So 1 into 0, 0. Minus 1 into 1, 0 into minus 1. So we get A dot B equals minus 1. As we have completed the dot product, let us proceed into modulus. Square root of squares. I tells us 1 the whole square. Minus J tells us minus 1 the whole square. 1 plus 1, it is root of 2. Modulus of B. Again, root of, add the squares. Here no number tells us 1 the whole square. Minus K tells us minus 1 the whole square. It also reduces to root 2. What is theta? Cos inverse A dot B. Answer is minus 1. Denominator mod A root 2. Mod B is also root 2. We get cos inverse of minus 1 by root 2 into root 2 is 2. We recall half for cos table. It is pi by 3. Negative symbol tells it is in second quadrant. So theta equals 180 minus 60 degrees, or I will say pi minus pi by 3. So I can say 180 minus 60, it is 120 degrees, or pi minus pi by 3 tells us 3 pi minus pi, which is 2 pi by 3 radians. Question number 5. If A, B, C are three vectors such that A vector plus 2 into B vector plus C vector equals 0 and modulus of each vector is given, find the angle between A and B. So this is the clue as to what I should do. When I want angle between A and B, in the given result, let us keep A and B to the left and the remaining to the right. So I have A vector plus 2B vector is minus C vector. Squaring on both the sides, we get A vector plus 2B vector the whole square is minus C vector the whole square. Let us recall the formula. What is A plus B the whole square? We get A square plus 2B the whole square plus 2 first vector dot second vector, that is equal to minus square is plus C square we get. What is A square? A square is 3 square plus 2 square is 4 and I have B square plus 2 into 2. We remember we can bring the scalars out. So 2 into 2 is 4 A dot B. What is modulus of C square? It is 7 square. As I simplify, I get 9 plus 4 into. What is B square? It is 4 square plus 4 into. What is A dot B formula? Mod A mod B cos theta equals to 7 square is 49. Again, let us substitute for mod A and mod B from here. So I get 9, 4 into 16 plus 4 into mod A is 3, mod B is 4 into cos theta equals 49. Simplifying, 9 plus 64 plus 4 4s are 16 into 3. 48 cos theta is 49, or 48 cos theta is 49 minus 9 minus 64. We get 48 cos theta is minus 24. Cos theta is minus 24 by 48, that is minus 1 by 2. Cos theta plus half tells me 60 degrees. Cos theta minus half tells me theta is 120 degrees, or I can say 2 pi by 3 radians, and that is the answer. Question number 6. Show that the vectors A, B and C are mutually orthogonal. The word orthogonal claims perpendicular or 90 degrees. So we say dot product of A and B, B and C and A should be 0. Let us find out the dot product for A and B. We know to multiply I and I. 2 into 6 plus J and J. 3 into 2 plus K and K. 6 into minus 3. That is 12 plus 6 minus 18, which is 0. Because A dot B is 0, we can infer A vector perpendicular to B vector. Similarly, let us find out B dot C. As before, I and I. 6 into 3 plus J and J. 2 into minus 6 plus K and K. Minus 3 into 2. As we simplify, 18 minus 12 minus 6, which is again 0. B dot C equal to 0 implies B vector perpendicular to C vector. Now let us find out C dot A. So finding C dot A, it is 3 into 2 minus 6 into 3 plus 2 into 6. We get 6 minus 18 plus 12. That is again 0. So I can claim C dot A 0 implies C vector perpendicular to A vector. From all the three, we have implied A vector perpendicular to B vector, perpendicular to C vector, and C vector perpendicular to A vector. A perpendicular to B, B perpendicular to C, and C perpendicular to A. Hence, we can prove A vector, B vector, and C vector are mutually orthogonal. Question number 7. Show that the vectors form a right angle triangle. Given the vectors, so let us check. whether they form sides of a triangle. What is the condition to form the sides of the triangle? Either I get A vector plus B vector is C vector, or I get A plus B plus C equals 0. As I look at this problem, I get minus I plus 2I minus I, 0. Minus 2j minus j plus 3j, 0. Minus 6k plus 5k, 0. So as we add A vector, B vector and C vector, we arrive at 0, which tells us A vector, B vector, C vector are forming the sides of a triangle. Now the question is a right angle triangle. So out of the three sides, any two should make 90 degrees. Whenever I say right angle or 90 degrees, dot product should become 0. So either A dot B or B dot C or C dot A will give us 0. So let us check B dot C. As I find out the dot product, we remember we multiply I and I, J and J, K and K, which gives us 0. So B dot C 0 tells us B vector is perpendicular to C vector. Therefore, A, B and C vectors form a right angle triangle. Question number 8 given. Modulus of A is 5, modulus of B is 6 and modulus of C is 7. Also, vector A plus B plus C equals 0. We need to find A dot B plus B dot C plus C dot A. Given A plus B plus C 0 and we want dot of each of the two vectors. Let us square on both the sides. We get A plus B plus C. The whole square is 0 square, which is 0. As I square, remember the formula A square plus B square plus C square plus 2A dot B plus 2B dot C plus 2C dot A equals to 0. So this is A plus B plus C the whole square, but we shouldn't be writing AB, rather A dot B, B dot C and C dot A. As we are given mod A is 5, it is 5 square. Mod B is 6, it is 6 square. Mod C is 7, it is 7 square. In all the three terms, 2 is common as we take 2 out. It is A dot B plus B dot C plus C dot A. And RHS we arrive at 0. So what is 2 A dot B plus B dot C plus C dot A? Bringing the terms to the right, 5 square minus 25, 6 square minus 36 and 7 square minus 49. We get minus 110. Therefore, A dot B plus B dot C plus C dot A equals, bringing the 2 down, it is minus 110 by 2, that is minus 55, and hence the problem is done. Question number 9, show that the points are collinear. Given the word points, consider the three as the position vectors, say OA, OB and OC. 2i minus j plus 3k, OA vector, 4i plus 3j plus k, OB vector, 3i plus j plus 2k, OC vector. To prove them to be collinear, let us find out what is AB vector. It is OB second minus first, so it is OB minus OA. 4i plus 3j plus k minus OA, change the symbol, minus 2i plus j minus 3k. We get 2i plus 4j minus 2k. This is AB vector. As we derive BC vector, it is OC minus OB. OC vector 3i plus j plus 2k minus OB, change the symbol, minus 4i minus 3j minus k. As we simplify, it is minus I minus 2j plus k. As I compare BC and AB, AB is nothing but 2 I can take as common, or even minus 2 I can take as common. It becomes minus I minus 2j plus k. So AB vector is nothing but minus 2 into BC vector. I am able to show AB is parallel to BC vector, but B, the point, is common for both. Whenever I am able to show two vectors are parallel and a point is common for them, it implies the points A, B, C are collinear. Remember, I cannot have AB like this and BC like this. Because it is the same point, it naturally claims the line to be like this. So A, B, C need to be collinear for the condition AB parallel to BC and B being common for both the vectors. Question number 10. If A and B are unit vectors, as I read unit vector, I declare modulus of A is 1 and modulus of B is 1. Theta is the angle between them. We need to show these three results. In all the three results, modulus of A minus B and modulus of A plus B are coming. Let us find out modulus of A minus B the whole square. So whenever modulus is asked in the question, consider the square of it, because we know the formula for A minus B the whole square. Even if it is modulus, square tells us I can apply the same formula. Say mod A the whole square mod B the whole square minus 2A dot B. As we simplify, mod A the modulus is 1. Mod B, the modulus is 1. 2. What is A dot B? Mod A, mod B, cos theta. So this is mod A minus B the whole square. 1 plus 1 is 2 minus 2. Mod A is 1, mod B is 1 into cos theta. In both the terms, 2 is common. I can write 1 minus cos theta. Let us recall trigonometry formula. 1 minus cos theta is 2 sine square theta by 2. As I multiply, 4 sine square theta by 2, which is nothing but mod A minus B the whole square. As I take square root on both the sides, I get mod A minus B equals 2 sine theta by 2. The same argument I can give with plus symbol. So the same steps. Consider A plus B the whole square. As I expand, mod A square, mod B square plus 2 A vector dot B vector. Mod A plus B the whole square equals mod A square is 1, mod B square is 1 plus 2. What is A dot B? Mod A, mod B, cos theta. As we simplify, 2 plus 2, mod A is 1, mod B is 1 into cos theta. 2 is common, it reduces to 1 plus cos theta. As we recall the trigonometric formula, 1 plus cos theta is 2 cos square theta by 2. 2 into 2, I get 4 cos square theta by 2. As we derive mod A plus B the whole square, let us find out the square root. Mod A plus B is 4 square root 2, cos square becomes cos theta by 2. My question is only cos theta by 2. It is mod A plus B divided by 2. So we have shown two results from the previous result. Sin theta by 2 equals 1 by 2 mod A minus B. Call it as number 1. From this, cos theta by 2 is half mod A plus B. Call it as 2. As I divide 1 by 2, I get sin theta by 2 by cos theta by 2. RHS 1 by 2 mod A minus B by half mod A plus B. We know sin theta by 2 by cos theta by 2 is tan theta by 2. Half cancels. We get mod A minus B by mod A plus B. So we have proved all the three subsections and hence the problem. Question number 11. Mod A, mod B, mod C are given. Also, each of them being perpendicular to the sum of the other two. We need to find modulus of A plus B plus C. Look at this sentence, each of them being perpendicular to the sum of the other two. If I take A vector, it is perpendicular to sum of the other two, B and C. If I take B vector, it is perpendicular to sum of the other two, that is A and C. Similarly, C vector perpendicular to A plus B. Whenever I use perpendicular, we mean dot product equal to 0. As we know the distributive law, A dot B, A dot C, B dot C, B dot A, and C dot A, C dot B. As we add all the three equations, A dot B, B dot A, 2 times A dot B, B dot C, C dot B, 2 times B dot C, A dot C, C dot A, 2 times A dot C. So 2 times I can keep as common. 2 into A dot B plus B dot C plus C dot A equals 0. Use this condition as 4. We need to find modulus of A plus B plus C. Whenever they ask modulus, let us consider the square of it because we know the formula only for the square. What is A plus B plus C the whole square? A square plus B square plus modulus of C square plus 2A dot B plus 2B dot C plus 2C dot A. As we know, mod A square given it is 3, so 3 square. Mod B square given it is 4, 4 square. Mod C square, 5 square. In all the terms 2 is common, I get A dot B plus B dot C plus C dot A. 3 square plus 4 square plus 5 square plus 2 into. This entire answer we have arrived at 0. So this is from result number 4. As I add, I get 16 plus 9, 25 plus 25, 50. Modulus of A plus B plus C, the whole square is 50. Therefore, modulus of A plus B plus C is, because it is modulus positive square root of 50, which can be written as 25 into 2 or it is 5 into root 2 and hence the problem is done. Question number 13. Find lambda when the projection of A on B is 4 units. The given vectors A, B and the projection are mentioned. Let us recall the formula. Projection of A on B. We know it is A dot B divided by on what? That should come in the denominator. So on B vector tells us divide by modulus of B. What is A dot B? As we know, we multiply I and I, lambda into 2, J and J, 1 into 6, K and K, 4 into 3. that is 2 lambda plus 6 plus 12. So A dot B, we arrive at 12 plus 6, 2 lambda plus 18. What is modulus of B? Root of squares of each component to be added. 2 square plus 6 square plus 3 square, or I get 4 plus 36 plus 9, that is 49, and the square root is 7. As I know the 2, let us substitute. What is projection of A on B given? It is 4. What is A dot B? 2 lambda plus 18. What is modulus of B? 7. As I cross multiply, 28 is 2 lambda plus 18. So 2 lambda is 28 minus 18. 2 lambda is 10. So lambda is 10 by 2, or we get lambda equals 5. So let us remember to find out A dot B, modulus of B, and the projection of A on B. Let us recall the formula A dot B by modulus of B. As we apply the value 4 and cross multiply and simplify, we arrive at lambda equals 5. Question number 14. Three vectors A, B, C are in such a way that mod A, mod B, mod C are given. Also A plus B plus C is 0. We need to find 4 times A dot B plus 3 times B dot C plus 3 times C dot A. To substitute in this result, we need to know what is A dot B, B dot C, C dot A. For which, let us use the given condition. So what is given? A plus B plus C equals 0. As I keep A plus B in the left and bring C to the right, squaring on both the sides, I get A plus B the whole square is minus C the whole square. It is A square plus B square plus 2A dot B, which is nothing but C square. As we know the modulus values in the question, let us substitute. Mod A 2 square, mod B 3 square plus 2A dot B is mod C, that is 4 square. So 4 plus 9 plus 2A dot B equals to 16. So what is 2A dot B? Bringing the numbers to the other side. 16 minus 4 minus 9. 2A dot B equals 3. Therefore, 4A dot B will be 6, as I need 4 times A dot B. So 4 times A dot B is 6, call it as number 1. The similar argument, let us find out B dot C. A plus B plus C is 0. Keep B plus C in the left and A to the right. The similar argument as we square. B plus C the whole square equals minus A the whole square, which is B square plus C square plus 2B dot C. It is mod A square. As I substitute from here, 3 square plus 4 square plus 2B dot C equals A square, that is 2 square. 9 plus 16 plus 2 times B dot C is 4. So 2B dot C equals 4 minus 9 minus 16. 2B dot C equals minus 21. So what is B dot C? It is minus 21 by 2. But I want 3 times B dot C in the question. As I multiply by 3, it is minus 63 by 2. Call it as number 2. In the similar steps, let us keep A plus C in the left and B to the right. Squaring mod A square, mod C square plus 2A vector dot C vector is mod B square. As I substitute the values, 2 square plus 4 square plus 2a dot c equals mod b square is 3 square. 4 plus 16 plus 2a dot c equals 9, or 2a dot c equals 9 minus 4 minus 16. 2 times a dot c is minus 11, or a dot c is minus 11 by 2. As I want 3 c dot a, c dot a and a dot c are equal. So I can just substitute 3 into minus 11 is minus 33 by 2. Call it as number 3. As we add 1, 2 and 3, I get 4 times a dot b plus 3 times b dot c plus 3 times c dot a equals 6 minus 63 by 2 minus 33 by 2, or we get 6 minus 2 is the LCM, 63 plus 33. We get 6 minus 96 by 2, or it is 6 minus 48, that is minus 42. Let us take and write the answer. 4 times a dot b plus 3 times b dot c plus 3 times c dot a equals minus 42, and hence the problem is solved.